Hey guys, this is going to be lesson 5. Keep in mind that this is not the beginning of the lesson. We'll have started the lesson during Google Meet, and this is going to be a lesson starting from question 13. We're actually talking about undefined fractions, okay? All right, so a fraction is said to be undefined when the denominator is 0. Remember, you can't divide a number by 0. If you try to divide a number by 0, you're going to get an error. If you try on your calculator, 5 divided by 0, for example, it says error divided by 0. See, it says error. So 0 cannot be in the denominator. You cannot divide by 0. So if we have algebraic expressions, not equations, just expressions, where just in this case it's a fraction with binomials or trinomials in them, we want to find the values where the fraction would be undefined. See, this fraction is fine, except for, you might notice, when x is 9. Because when x is 9, 12 over 9 minus 9 would be 12 divided by 0. That's going to be a problem. So we're going to try to find the values for where we got a problem. And the way you do that is set the denominator equal to 0 and solve. And that's going to give you your problem value. So x equals 9 is where this fraction is going to be undefined or meaningless, okay? So we can do that in all these cases. We're basically here. Let's take a look. We want to see when this fraction is undefined. The numerator is irrelevant. It's just the denominator. We're going to want to take that denominator and set it equal to 0. Here, there's a Gcf factoring you could do. You could pull out an x plus 7 equals 0, make a t-chart. X equals 0, x equals negative 7. So when x is 0 or when x is negative 7, this fraction will be undefined. It's important that you know this, because if you go into more advanced math, then you need to know that values like this won't work in this expression. And if you go on to pre-calculus or calculus, you'll see that that's going to give us a problem. So you got to be aware of those issues, okay? All right, let's try the next one. So again, we want to set the denominator equal to 0. That's going to find for us where the fraction is undefined. So in this case, it's going to be 2/3. When x is 2/3, fraction is undefined. Here we have a trinomial, but it's factorable. X squared plus x minus 42 equals 0. You're going to factor this. Remember, find two numbers that multiply to negative 42, but add up to 1. I'll put a 1 in there. That looks like 7 and 6. 7 and 6 multiply to 42. You're probably going to want a positive 7, negative 6. And when you do your t-chart, these are the values for x for which this fraction is undefined. When x is negative 7 and when x is positive 6. All right, next one, same thing. You could try these on your own. It's good to see if you can get these on your own. There'll be some on the homework problem. So again, we could factor this. This is a difference of 2 squares. So here we get the fraction is undefined at negative 3, and when x is positive 3. And this one is really easy. This is undefined simply when x is 0. So it's really simple to find out when a fraction is undefined. Simply take the denominator, set it equal to 0, solve, and that will give you the problem that the fraction will have no meaning, will be undefined. All right, the other thing we're going to do in this video is simplify these rational expressions. So we got this fraction here, x squared minus 16 over x squared plus 2x minus 24. I don't know how well you can see this. I'm going to hold it up closer to the camera for you. So the issue here is this stuff is factorable. And when you factor x squared minus 16, it becomes x minus 4 and x plus 4. And when you factor x squared plus 2x minus 24, remember, two numbers that multiply to negative 24 and add up to 2, you're going to be using a 6 and a negative 4. So after you factor the numerator and denominator, you see that the x minus 4s actually divide out. Because if you cancel them out, they divide to 1. X minus 4 divided by x minus 4 is 1. What do you have left? X plus 4 over x plus 6. This is this same fraction. They're identical to each other. But this is the simplified version of this fraction, okay? So we're going to practice this skill, okay? So you're going to follow along. Let's take a look. All right, so next problem. X squared plus 7x plus 10. Trinomial, you need two numbers that multiply to 10 and add up to 7. So you're going to have an x plus 5 and an x plus 2. Denominator is just find a GCF. It's going to be 5. 5 and then x plus 2. X plus 2 is divide out to 1. So your final answer is going to be x plus 5 over 5. And there's nothing you could do here. Don't try to divide these 5s. Because when you have a binomial divided by a monomial, the only way you can divide this 5 out is if you divide it into everything. And since the 5 doesn't really go into the x evenly, don't try to cancel these or divide these to 1. That's not going to work, okay? All right, let's try this. Numerator, pull out a greatest common factor of x. X parentheses x minus 3 over 3x. What you might notice here is that the x's divide out to 1. And what you have left, I'll put it in black here like this, is x minus 3 over 3. And again, don't try to divide these 3's because you would have to divide by 3 on both sides, not on both parts. But you could do it this way. This is going to be x divided by 3, and this is going to be negative 1. You could get this, but a lot of people will just divide the 3 into the 3 and just get a 1 here, a minus 1 here, and leave the x alone, but that's not what it is. I suggest just leaving the fraction this way, x minus 3 over 3. All right, next one. And again, I would pause the video, try some of these yourself, see if you could do them. Here we can pull out a 2x, greatest common factor of 2x, then x minus 3. Denominator is 6x squared. The way we can simplify this is 2 goes into 6 3 times, so 1/3. One of these x's cancels out. So what we have left is x minus 3 in the numerator over 3, and then one of the x's canceled out, 3x. So that's how this became simplified. All right, next problem. You got two trinomials. They're both factorable. Let me write this a little bit larger. X squared plus x minus 20 and x squared plus 2x minus 15. For the top polynomial, for the top trinomial, two numbers that multiply to negative 20 and add up to positive 1. That's going to look like a positive 5 and a negative 4. That multiplies to negative 20 and adds up to negative 1. Denominator, two numbers that multiply to negative 15 and add up to 2. It looks like 5 and negative 3. X plus 5 and x minus 3. These divide out to 1, so what we have left is x minus 4 in the numerator and x minus 3 in the denominator. Okay, this one, it looks like this one is a trinomial, but there's also a GCF, so we're going to have to factor this one completely. Factor it completely by first factoring out the GCF. So now you're going to get x squared plus 8x plus 12. Just pulled out an x there, and now we could factor that some more. This thing, that's going to become x and x plus 6 and x plus 2. 6 times 2 is 12 and 6 plus 2 is 8. And that's going to be over x plus 6. These divide out to 1. So what we have left is just x times x plus 2. And these fractions are equivalent, but obviously this is the simplified version of that fraction. Okay, something to keep in mind here. Let's factor it fully, and then I want to point out something to you. So the top is going to be factored by pulling out a GCF, which is 2. 2 and 4 minus x. The denominator is dots, difference of two perfect square, x plus 4 and x minus 4. Now, these look similar, but they're not exactly the same. 4 minus x and x minus 4 aren't identical. So I'm going to show you something now and what to do in such a case, all right? So here's the thing. If I have x minus 4 over x minus 4, these things are identical. This is just 1. But if I have x minus 4 over 4 minus x, this isn't going to be 1. In fact, this is exactly the opposite of this. Wherever this number is on the number line, let's say it's at 7, then this one is going to be the opposite case at negative 7. And what do I mean? Let's say x is 11, okay? So 11 minus 4, x is 11, 11 minus 4 is 7. But 4 minus 11 is negative 7. So these are actually opposite values. You can check for yourself. Like you can put numbers in there. Let's say x is, 5. So let's try it. 5 minus 4 over 4 minus 5. The top is going to be 1. The bottom is going to be negative 1. That's negative 1. Let's try another one. Let's try x equals negative 6. Let's see, negative 6 minus 4 over 4 minus negative 6. Well, negative 6 minus 4 is negative 10. 4 minus negative 6 is positive 10. So I want you to notice that every time you do this, no matter what value for x you put in, it divides to negative 1. So this over this is not equal to 1, so they just won't cancel out. Instead, they divide to negative 1. So what do? When we cancel them out or divide them out, we're going to leave a negative 1 in its place because we know these divide to a negative 1. So let's go back and take a look what happens over here. So we got our 4 minus x divided by our x minus 4, and that's going to leave a negative 1. So what do we got? 2 times negative 1 is negative 2. The bottom is not going to be affected. The negative is on top here. So it's going to have an x plus 4 on the bottom. So it's going to be negative 2 over x plus 4. Now, if you hadn't known that, and you just cross these out, you would have gotten positive 2 over x plus 4. But again, whenever you have a fraction where these are exactly reversed of each other, x minus 6, 6 minus x, what you get is a negative 1, and you just, when you go to divide them out, leave a negative 1, most preferably in the numerator, but it doesn't matter. As long as you leave a negative 1 either in the numerator or in the denominator, it'll be fine. All right, let's try some more practice and see if we can come up with more examples like that. Not here. Here we're going to have a GCF of 2 and 3 plus x. And denominator is going to be x plus 3 and x plus 2. Now you might say, oh, if we cancel these out or we divide these out, we're going to put a negative 1 there. No, these aren't negatives. And besides, they're exactly the same. Because of the commutative property of the commutative property of addition, you can add numbers in either way. It's the same thing. So these are actually identical, and you get 2 over x plus 2 here. All right, let's try to factor this one. So we're going to get x plus 7 for the numerator and x minus 2 and x plus 2, x minus 2. These are identical, so those divide out to 1, and we get x plus 7 over x plus 2 there. Here's where we're going to get something interesting. Here's a dots problem, but the number is first. So that's going to become 6 plus x and 6 minus x. The denominator, we need two numbers that multiply to 18 but add up to negative 9. I think that's going to be a negative 6 and a negative 3. Negative 6 times negative 3 being 18. Now 6 minus x and x minus 6, that's the issue we just talked about. It's not going to be 1, it's going to be negative 1. So when we cancel them out, we're going to get a negative 1 there. So our final answer is going to be negative 6 plus x over x minus 3. And it's because of this issue that we get the negative here, and this is going to be our reduced form. All right, for number 28, we're going to pull out a GCF on top, 2x squared minus 9, but then we can factor this more. So this is basically a factoring completely on top here. So we get 2x plus 3 and x minus 3. And in the denominator, we need two numbers that multiply to negative 3 and add up to negative 2. So it's going to be negative 3 and positive 1. So these will divide to 1. So we got 2 parentheses x plus 3 over x plus 1. All right, couple more problems. For what values of x is the following function undefined? It's not asking you for you to simplify this. It's just asking you when will the denominator be 0. So if you remember, that's what we started the video with. We're going to set just the denominator equal to 0 and solve. So we got 4x equals negative 10. And we're going to get x equals negative 2.5. When x is negative 2.5, this fraction will be undefined, and 30 is the same thing. When will this fraction be meaningless? That's the same thing. When is it undefined? It's just the denominator we care about. We're going to set the denominator equal to 0 and factor this. Two numbers that multiply to 12 and add up to 13 are 12 and 1. When we solve this, these are our issues. X equals negative 12 and x equals negative 1. Those values are going to make this fraction undefined because it's going to make the denominator 0. Okay, you should know enough now to work on your homework assignment.